ओके, झालं चालू रेकॉर्डिंग.
ओके सर, थँक्यू.
पाहून घेऊ ते कुठे आहे, तर जिथे होईल सेव्ह तिथे.
ओके सर, थँक्यू. हो चालेल सर. ओके ठीक
ओके,
आहे सर.
ठीक आहे. So then the next head is the elliptical head. It is also called as the semi-ellipsoidal head. It is also called as the semi-ellipsoidal head. Now in this figure, you can see the industrial view. There is a big machinery which is, hello, huh? Bola sir. Okay, in this figure, there is a big machinery which is provided, which is going to put a dishing that has been done. That means for a flat plate, I am going to hammer it continuously so that it is forming a dish. Curvature ban raha hai. So such this dish that is formed by continuously pressing it. And similar videos are available on the net, and I request all of you to watch these videos. Hello, class चालू है sir, class चालू है. So it is also called as क्लास चालू आहे, नंतर फोन करा. हॅलो. The point of maximum stress in the head recorder. So you can form the dishing by simply hammering it continuously. That is, the ratio which is obtained for this is generally 2:1 or 2.6:1. The heads shallower than the ratio of 2.5, maximum stress is in the tangential direction at the outside surface of the knuckle region, and it is in compressive stresses. The head is provided with a straight flange portion. In this figure, second figure, you can see a simply straight flange portion which is provided, and this is generally 15 to 20 millimeters, and these heads are used above 15 kgs per centimeter square. Torispherical heads, they are used from 1 to 15 kgs per centimeter square pressure. Now the pressure is increased, then you are going to use the elliptical head. That is going to provide the more uniformity in the stresses. The thickness that can be calculated as PDV upon 2Fj. Now this way, V is the stress intensity factor. V is the stress intensity factor. Again, PD upon 2Fj, that is our standard formula for calculation of the thickness, where V is 1/6 into bracket 2 plus K square. Now if the knuckle radius major axis to the minor axis ratio is 2:1. So K is the major axis to the minor axis ratio. K is the major axis to the minor axis ratio. Means Major axis is 2 times and the minor axis is 1 times. So k square, that will be 4. And so 2 plus 4, that is 6, and V will become equal to 1. So for the stresses, for the ellipsoidal head with the major axis to the minor axis ratio of 2:1, V that will become equals to 1. And this thickness will be equals to the thickness of the head, thickness of the shell. That is the thickness of the shell, and the thickness of the head, that will be same. When V equals to 1, when V will be equals to 1, that will be the major axis to the minor axis ratio is 2:1. Now in this case, I can simply ask the small objective questions on this slide. That is, what is the generally the major axis to the minor axis ratio that is used? That is 2.1, 2:1 or 2.2:1. Now in which range of this pressure range, what will be the pressure range for elliptical head? It is above 15 kgs per centimeter square. What is the formula for calculation of a thickness? Then what is stress intensity factor? What is K? Now, when the thickness of the vessel and the thickness of the head, that will be the same. When the thickness of a vessel and the thickness of a shell, that will be the same. So 5 to 7 questions that can be framed on this single slide. So similarly, we are going to conduct the objective test MCQs in the next week. I am going to provide you the link on the Moodle next week. Next week we are almost going to switching over to the Moodle. So all the tests and its marking, that will be done in the Moodle. Again, I suppose some of you must have completed the assignments except the jackets. बाकीचं सगळं झालेलं असायला पाहिजे. Next week I am going to ask you to submit the complete assignment, and that will be within 2 days intimation, because I have already provided you the sufficient time to write all these assignments. So only 2 days will be provided to you for uploading of the assignments in the next week, and there will be the test on this first unit. Around 30 questions test that will be there in the next week. So how the questions that can be framed, I have talked in this slide. 4 to 5 questions, 4 to 7 questions that can be framed on a single slide. So you have to study that in details. Now next, hemispherical head. It provides the maximum volume and requires just half the thickness of cylindrical shell, that is PD upon 2FJ and PD upon 4FJ. So the thickness calculation is PD upon 4FJ for hemispherical vessels. For spherical vessels or for hemispherical vessels, thickness that is calculated as PD upon 4FJ. For cylindrical vessels, the thickness that is calculated as PD upon 2FJ. कधी कोणचा फॉर्म्युला यूज करायचा आहे हे ज्यांनी न्यूमेरिकल्स केले त्यांना समजतं ते. This head is difficult for fabrication, and the cost of fabrication is very high for such type of the heads. Now what is that? This is the, you can see the second figure. The certain curvature that is provided, and all these curvatures, they are welded to form a hemispherical head. Now forming such a head, such a shape, and then welding the different such formed shape, that becomes a complicated process. So its cost is more. Even though the thickness required is half, the cost of fabrication is much more than your torispherical head and elliptical heads. So they are specially used at special purposes. It involves more drawing work and the die cost. Then discontinuity stresses are minimum, thickness that is minimum. These are the advantages. However, the cost of fabrication is a major disadvantage for these hemispherical heads. Now next is a conical head. Conical heads, they're commonly used as the bottom. Generally used as the bottom. Bottom में आएंगे ये सारे conical heads. Now where they are used? At the evaporators. Bottom of the evaporators, where the concentrated liquids they are taken out. Then the cyclone separators. Cyclone separators, you must have seen the cyclone separator in your SFO. Then hydrocyclones. So these are the conical heads, not only to the evaporators, cyclone separator, hydrocyclones, but it is also used for the silos, that is the bottom that can be used. Hydrocyclones. The silos. Now what are the silos? The big storage tanks for the solids. Big storage tank for the solids. They are called the silos. In industries, if the chips, polymeric chips or grains, you want to store it in the industrial scale, then the big silos will be there, and at the bottom you are having a conical shape. Why this conical shape? It facilitates the movement of the solid granules. The solid granules will very easily flow through this conical shape, and this facilitates the draining of the product of the material. Where draining that is required, viscous draining, solid draining that is required, it is preferred with a conical bottom. However, the liquids with lower density, we can have the dished head also. Dished head में से यहां से इतना ही कर्वेचर है फ्लो होने के लिए, इतना ही कर्वेचर है फ्लो होने के लिए, बट कोनिकल सेक्शन में स्लोप ज्यादा है. जनरली इट इज द 60 degrees that is used. The cone having an apex angle of 30 degrees are commonly used. This is half the angle what I have talked. If the total angle, that will be 60 degrees. Total angle is 60 degrees. Apex angle, cone, total angle is 60 degrees. Half the angle, that is 30 degrees. At the bottom, alpha, which is equal to half apex angle of the cone, that is 30 degrees generally that is used. Then a junction of the cone to the cylindrical shell has to be specially considered while designing the conical head. Then a compression ring is provided at the junction of the cone and the cylinder. At the junction of the cone and the cylinder, the certain rings that can be provided. The thickness calculation now, that is the same formula, PD upon 2FJ into 1 upon cos alpha. The same formula that is modified. Sometimes it is M, sometimes it is V. Now it is 1 upon cos alpha. 1 upon cos alpha. By this factor of 1 upon cos alpha, your thickness that is going to increase. Then head subjected to the external pressures. Generally, the thickness calculations are similar to this external pressure vessels. Then the internal pressure 1.7 to 2.7 times that can be taken into account. Now there is another term, that is the blank diameter of hemispherical head. Blank diameter of hemispherical head. What is the blank diameter? Now to form such a head with this diameter, I will require more length. So the diameter of a circular plate that is required to form a hemispherical head, torispherical head, or elliptical head, or dished head of certain radius with a straight flange. So even though I am using this thickness plate, I can only provide effective diameter with this only, because some amount of the material that will be required for the bending or curvature and certain length that will be required for the straight flange portion. So straight flange portion of 15 to 20 millimeter, that is 2 centimeters. Then a certain curvature which is going to provide a knuckle radius, and then the dished head, that is the crown radius. प्रत्येकाला हे applicable आहे. Crown radius, knuckle radius, that will be there everywhere. Even though the curvature, that is nothing but a curvature. In ellipsoidal, that is the major axis to the minor axis, but there are also curvature. वरचा जो आहे curvature, that is having a higher radius, and at the end the radius is less. So blank diameter, that is the nothing but the diameter of a circular plate required to form a hemispherical head of radius r and with a straight flange portion f. Now for this hemispherical head, the calculation of the diameter, we are using this formula, where f is the width of a straight flange portion, or it can be called as the SF also, and r is the radius of the hemispherical head. Then how to select the most economical head? That is based on the material cost, fabrication cost, and the type of the head. What is the purpose? You have to draw all these different heads. That is the standard shallow dished head, that is to be drawn. At the corner there is certain curvature that is provided, and the straight flange portion that is also provided. Then the torispherical head are K knuckle radius, small amount of the straight flange portion that is provided. While drawing, you have to understand the different concepts also. Similarly, draw elliptical head, hemispherical head, and the conical head. Now in this figure, alpha that is shown as, in both the figures alpha that is shown, but in this figure, upper figure, the alpha is complete, and in the bottom figure alpha is half the apex angle. You have to understand this half the apex angle that is used in the formula 1 upon cos alpha, that is alpha is the half the apex angle, and then you can have a straight flange portion. Then the economic head. As the metal becomes more and more expensive, it becomes necessary to use the thinner material and the small blank diameter for forming a head. Means the basic material cost that will be taken into account. Minimum thickness and the minimum plate that will be required. minimum thickness and the minimum plate that will be required. Then the thinner material requires more severe configurations. You can think that the hemispherical heads, they are with the minimum thickness. Hemispherical heads, they are with the minimum thickness. So that is what the thinner material requires more severe configuration, more severe curvatures they are required. Now here you have to optimize between the curvature and the thickness. Here you have to optimize the curvatures provided, which is nothing but the cost of fabrication. So the designer should select a head thickness that can be formed as economically as possible. Then manufacturing cost is based on combination of shape, thickness, method of forming, then the types of the head, that is related to the selection, economic cost. Generally the hemispherical heads are torispherical head, elliptical head are commonly used for the process equipments. Then the hemispherical head is used for the special purpose because it is very costly and difficult to fabricate. Perfect hemisphere मिलाना, fabricate करना is that it requires higher instrumentation, higher cost of machinery basically. Then elliptical heads are used for the pressure above 15 kgs per centimeter square and requires higher thickness and is very difficult and costly to fabricate. Then torispherical heads and dished heads, they are more easy to fabricate. Torispherical and shallow flanged dished head has been very common for low pressure operations. The torispherical head with 106, that means 100 is RC and 6 is RK. This design is most common. That means the radius equals to the diameter of the vessel. 100 is radius is equal to the diameter of the vessel. That is what our formula is, PRC or PD also. D when the diameter is 100 or it is RC. That is the crown radius and it is in 80%, 90% or 100% of the vessel diameter. For economic reasons, 80 to 10 heads that can be used. So you can draw in this figure, you can see the different shapes, different dishing that has been provided. These are simple figures, but you have to look it in the details so that you can understand the dishing. कितना curvature provide किया है ये समझने का है इन figures में. This one is more or simply a flat plate similar to your cap, and this is most easy to fabricate. Then as you are going up, the curvature that has been provided, more curvature, again the curvature, proper curvature that has been provided in the corner, means knuckle radius. Knuckle radius चा curvature जेवढा crown radius च्या curvature सोबत match होईल तेवढं तुमचं cost of fabrication वाढतं. Then hemispherical head, and this is simply the flat head. So these are the different types of the heads that is there. Now we will see the numerical associated with this we'll see the numerical associated with this. So coming to the formulas. Now the hemispherical head, this is in terms of the internal diameter. This formula is in terms of the internal diameter. Or you can simply use PD upon 4FJ or PDI upon 4FJ minus 0.4 PI. Similarly, you can write it for the outer diameter also. Then the formula related to the elliptical head. Then to the torispherical head, here RC, that is crown radius. Then blank diameter, this is what the same we have seen it. This is what if fabrication is being done in the industries. Look at the second figure, a big head that is being formed, and here the hammer that has been a big industrial scale hammer that is used for dishing. Not only that, a certain roller that is provided. This is for the roller, and it is increased at its temperature, that is increased. That is why it looks red. The temperature is more. As the temperature is more, the fabrication becomes more and more easy. This is for rotation of this dish. This support is for rotation of this dish. This ball is for providing a dishing. Crown radius provide करने के लिए है वो ball. You can see the different videos associated with. So heating that is also required for this type of the head. Now the numerical. कोणाला काही डिफिकल्टी आहे का? कोणाला काही डिफिकल्टी आहे का?
सर वो क्राउन रेडियस इज इक्वल टू डायमीटर वाला बताया, वो थोड़ा समझ में
काय?
क्राउन रेडियस इज इक्वल टू डायमीटर वाला कुछ बताया, वो समझ में.
ओके, क्राउन रेडियस आणि डायमीटर. ओके, न्यूमेरिकल मध्ये मी सांगतो तुम्हाला. Now consider this numerical, that is calculate the thickness of torispherical head 106. Head torispherical with 80 and 10. Here ratios are. Then elliptical head 2:1, and the hemispherical head for a vessel having 1 meter diameter and having the desired pressure of 3.5 kgs per centimeter square. The welded joint efficiency is 100%. Permissible stresses जर न्यूमेरिकल मध्ये दिलेल्या नाहीत तर you can take permissible stresses as 900, 800 kgs per centimeter square, 900 kgs per centimeter square, 1000 kgs per centimeter square, 1200 kgs per centimeter square or up to 1400 kgs per centimeter square. जर कुठे जर दिलेले नसतील तर you can take this permissible stresses for material of construction. You can assume that sometimes, but if it is only when it is not given mentioned in the numerical. Now the vessel is having a diameter of 1 meter diameter, and the torispherical head is ratio with the 100 to 6. Torispherical head with a ratio of 100 to 6 that is mentioned. That means the meaning of a crown radius RC, that is equal to the diameter of the vessel. When it will be? When it is 100. When this ratio is provided 100, then the meaning of the crown radius equals to the diameter of the vessel. Now come to the second part. The thickness of a torispherical head, this is the ratio is mentioned as 80-10. This ratio mentioned is the 80-10. So crown radius, that will be the 0.8 times into 1. 1 is what? The vessel diameter. In this case, 1 is the vessel diameter. So 0.8 times the vessel diameter. That means 0.8 will be the crown radius. Now see the next example also. इथे next example मध्ये vessel diameter is 1.5 meters, that is mentioned. Vessel diameter is 1.5. So crown radius will be equals to 0.8 into 1.5 meters. This is for 80-10. जिथे 80 आहे, that will become 0.8 times the vessel diameter. 1.5 is the vessel diameter. वरच्या एक्झाम्पल मध्ये होतं 1 as the vessel diameter. हे दुसरं एक्झाम्पल आहे, ह्याच्यात 1.5 आहे दिलेला vessel diameter. So that is to be multiplied. आलं का लक्षात?
सर जे की वैल्यू कैसे लेनी है?
J की?
यस सर.
J is the welding efficiency. In general case,
यहाँ पर 10 कैसे लिया है?
हाँ?
यहाँ पर 10 कैसे लिया है सर आपने ये क्वेश्चन में?
ओके, ये टाइपिंग मिस्टेक है, दैट इज
1 पॉइंट होना चाहिए ना.
100.
अच्छा सर, फिर वो नीचे सर फॉर्मूला में लिखते हो सर, आपने 1.0 लिखा है ना. ठीक है, टी का फॉर्मूला है सर वो.
एक मिनट,
थिकनेस का.
ये यहाँ पे क्या दिया हुआ है? न्यूमेरिकल में जॉइंट एफिशिएंसी इज कंसीडर्ड एज 100%, राइट?
यस सर.
So this J, that is 1. Now this
1.
formula, that is T, here it is the 1.0 that is mentioned.
यस सर.
इथे J 1.0 पाहिजे, तिथे पॉइंट टायपिंग मिस्टेक आहे ती.
ठीक है सर.
Now the formula is thickness which is equal to PDM upon 2FG. हाँ, ते समजलं का? RC आणि RK?
यस सर.
ज्यांनी डिफिकल्टी विचारलं होतं त्यांना समजलं का?
सर सेकंड एक्झाम्पल मध्ये जेव्हा जे डायमीटर होतं ते 1.5 होतं, तेव्हा अपन 106 में मल्टीप्लाई करना पड़ेगा क्या उसको?
काय रिपीट करा थोडासा आवाज जवळ घेऊन बोला ना थोडंसं.
सर जब सेकंड एग्जाम्पल में डायमीटर 1.5 था, तब भी उसको जब 100 से 80 वाले में तो हमने किया ही मल्टीप्लाई, उसको 100 वाले में भी मल्टीप्लाई करेंगे क्या?
100 है तो उसको 1 से मल्टीप्लाई करने का है. 80 है, दैट इज परसेंटेज. 100 is 100% of the vessel diameter. 80 is the 80% of the vessel diameter. 6 है तो 6% of the vessel diameter. 8 है तो 8% of the vessel diameter. 10 है तो 10% of the vessel diameter. That means I have to multiply it by, when it is 106 for crown radius, 100 that is representing the crown radius and 6 that is representing the knuckle radius. So crown radius के calculations के लिए मेरे को 100 times लेने का है. That is what? It is multiplied by 1. Now for calculation of the knuckle radius, it is 6. So I have to multiply it by 0.06. Multiply it by 0.06. इथे 10 आहे तर 0.1 ने मल्टिप्लाय केलेलं आहे.
सर तो
और
वो
simply you
1
can-
से मल्टीप्लाई तब करेंगे ना जब जो डायमीटर है वो 1 है, तो सेकेंड एग्जांपल में तो 1.5 था, तो उसका क्राउन रेडियस 1.5 ही हो जाएगा क्या डायरेक्ट?
नाही नाही नाही, जेव्हा 100 आहे तर क्राउन रेडियस इक्वल्स टू द डायमीटर झालं. पण जेव्हा 10 आहे तेव्हा मला मल्टिप्लाय करावं लागेल 0.8 मल्टिप्लाइड बाय द डायमीटर.
ठीक है सर.
See at this numerical, so the crown radius that is calculated in this numerical, that is the crown ratio दिलेला आहे 80-10. 80-10 दिलेला आहे रेशो ह्या एक्झाम्पल मध्ये आणि व्हेसल डायमीटर आहे 1.5 आहे. तर 0.8 नी मल्टिप्लाय केलेलं आहे व्हेसल डायमीटरला. 1.5 इज द व्हेसल डायमीटर and the ratio mentioned is the 80. So 80 च्या ऐवजी 0.8, that is the 80% है. 80% of the vessel diameter. 80% of the vessel diameter मेरे को कैसे लिखना पड़ेगा? 0.8 multiplied by the vessel diameter. 80% of the vessel diameter. How I can write? 0.8 multiplied by the vessel diameter. Right? So similarly, knuckle radius is the 10% of the vessel diameter. 10% of the vessel diameter. 10% that is 0.1 multiplied by the vessel diameter. इथे vessel diameter जर 1 असता तर 1 ने मल्टिप्लाय केलं असतं मी. ह्या एक्झाम्पल न्यूमेरिकल मध्ये vessel diameter 1.5 आहे. तसंच अजून पुढचं एक्झाम्पल पाहूया आपण. नाही एवढेच आहेत. जर व्हेसल डायमीटर जर 3 असेल तर इथे आरके कॅल्क्युलेट करताना 0.1 मल्टिप्लाइड बाय 3 करावं लागेल. आरके कॅल्क्युलेट करताना 0.1 मल्टिप्लाइड बाय दी 3. 10% of the vessel diameter. This is 80% of the vessel diameter. 100% of the vessel diameter. 100% of the vessel diameter म्हणजे मला काय करतोय मी 1 नी मल्टिप्लाय करतोय. 80% of the vessel diameter आहे तर मी 0.8 नी मल्टिप्लाय करतोय. 10% of the vessel diameter आहे तर मी 0.1 नी मल्टिप्लाय करतोय. 6% of the vessel diameter आहे तर मी 0.06 नी मल्टिप्लाय करतोय. आलं का लक्षात? लक्षात आलं का?
यस सर.
हो सर.
ओके. कारण की याच्यात हेच मेन पॉइंट आहे, बाकी तर सिंपल आहे प्रोसेसेस. Now how to calculate the m? m is nothing but 1/4. m चा फॉर्म्युला काय ते लक्षात पाहिजे आपल्याला, नाही तर m चा फॉर्म्युला आपण चुकीचा लिहितो परीक्षेत. m which is equal to 1/4 3 plus root of rc upon rk. इथे तुम्ही मल्टिप्लाय नाही केलं तरी चालेल. यू कॅन सिम्पली राईट द रेशो ऑल्सो. 100/6 मल्टिप्लाइड बाय 1, खाली पण 1 नी मल्टिप्लाय होईल आणि न्यूमरेटरला पण 1 नी मल्टिप्लाय होईल. तर त्यामुळे यू कॅन एलिमिनेट दॅट. But while using this formula for calculation of the thickness, it is the 3.5 is the nothing but the pressure into 1, that is the vessel diameter, PD into m. m च्या व्हॅल्यूज है जनरली स्टँडर्ड आहे 1.77, 1.44, 1.43, 1.44 ह्या जनरल स्टँडर्ड व्हॅल्यूज आहेत, त्याच येतात त्या. कारण की रेशोज आर ओनली दॅट 100/6, 80/10, 90/10 or 98. These ratios are more or less same. तर त्याच्यामुळे न्यूमेरिकल व्हॅल्यूज पण m च्या त्या जवळपास सारख्याच येतात. Then the second calculation, that is related to the torispherical head with the 80/10. Here this crown radius 0.8 into vessel diameter, that is 1, knuckle radius 0.1 into vessel diameter 1. So similarly now you can see the difference of the value of m. वरच्या न्यूमेरिकल मध्ये 1.77 ची m होती, इथे 1.457 आहे. So your final thickness that comes out to the 2.04 mm. वरची आहे 2.47 आहे. Then for the thickness of elliptical head, major axis to the minor axis ratio 2:1. Now so V that is calculated as 1.0. This is what I have talked. In case the thickness of the vessel and the thickness of the head, that will be same in this case. That is the thickness that will be calculated PdV upon 2fj. This is 3.5 into 1 into the V. This V is 1.0 upon 2f and j is 1.0, which is equal to 1.4 into 10 to the power minus 4 meters. That comes out as the 1.4 millimeter. And if it is the hemispherical head that has been used, then PD upon 4fj. Now comparing all these thicknesses, किती आहे thicknesses त्याच्या? वर्षाची 2.4, 2.04, then 1.4 and 0.7. Now if I will calculate the thickness of a vessel in this numerical. What will be the thickness of vessel in this numerical? That will be the same as the 1.4 millimeter, because PD upon 2fj. I am going to use this formula. The same as the elliptical head चा जो फॉर्म्युला आहे तो यूज करतोय मी. V ची व्हॅल्यू इथे 1 आहे. व्हॅल्यू ऑफ V is 1 because ratio is 2:1. Now if I will change the ratio as 2.6:1, if the ratio that is changed to 2.6:1, so value of V that is going to change, that will increase. So my thickness that will be increased. So for hemispherical head, you require a minimum thickness of 0.7 millimeter. Then the thickness of the vessel 1.4 millimeter. In this case, the thickness of an elliptical head that is also same as that of the cylindrical vessel, because the ratio is 2.1. Then with the 80/10 ratio, the thickness comes as 2.04. कर्वेचर जसं जसं वाढत चाललेलं आहे तशी तशी थिकनेस कमी होते आहे. As I am going to increase the curvature, I am getting a lesser thickness material, right? But in actual practice, I cannot use this 0.7 millimeter thickness neither for fabrication nor for welding purpose. Minimum thickness that is required is the 5 millimeter. Minimum thickness required is the 5 millimeters for the purpose of welding. Welding should be properly done. It requires a thickness of 5 millimeter. So even though my thickness that is coming as 0.7, 1.4, 2.04 or 2.74, I am going to use the thickness of 5 millimeter. This has to be mentioned at the end. इथे तुम्हाला मेन्शन करायचं आहे thickness used is the 5 millimeter. This comments I have written in the pressure vessel चे जे न्यूमेरिकल्स तुम्हाला पाठवलेले आहेत त्याच्यात हे घेतलेले आहे, मेन्शन केलेले आहे तिथे हे comments. Then the percentage reduction in the thickness. So maximum thickness that is 2.478 for a elliptical head, torispherical head with the 106. So 2.04 is the thickness with a torispherical head 80-100. So percentage is 17.7%. So similarly elliptical head also you can calculate. So similarly you can solve the other problems. Numericals पण दिलेले आहेत. काही डिफिकल्टी आहे का न्यूमेरिकल्स मध्ये? हेड्सच्या न्यूमेरिकल्स मध्ये काही डिफिकल्टी आहे का आता उरलेली?
रेडियस आणि क्राउन रेडियसच्या कॅल्क्युलेशन मध्ये अजून प्रॉब्लेम जातो सर.
काय एक्झॅक्टली काय जातोय?
तर ते कन्फ्युज होत आहे सर. ते क्राउन रेडियसला काय मल्टिप्लाइड केलं डायमीटरने आणि फर्स्ट मध्ये 100 to 6 मध्येच का नाही केलं मल्टिप्लाय?
100 to 6 मध्ये 100 नी 100 म्हणजे 100% आहे ना ते बेटा. 100% म्हणजे मल्टिप्लाय कशाने करणार तुम्ही? 1 नी मल्टिप्लाय करणार. 100% आहे म्हणजे 1 नी मल्टिप्लाय करताय ना. 80% आहे म्हणजे 0.8 नी मल्टिप्लाय करताय. 10% आहे म्हणजे 1 नी मल्टिप्लाय करताय. 6% आहे म्हणजे 0.06 नी मल्टिप्लाय करताय. प्रत्येक ठिकाणी मल्टिप्लाय करायचंच आहे. पण ते कितीनी मल्टिप्लाय करायचं आहे ते व्हॅरी होत आहे. 100 आहे तर 1 नी मल्टिप्लाय
100 to 6
तर तिथे मल्टिप्लाय केलेलं आहे ना. हे ते 6% आहे. 6% न म्हणता मी 0.06 लिहील.
100/6 पण घेऊ शकतो का?
हा, दिस इज इक्वल टू, आता मी लिहितो इथे, इज इक्वल टू नथिंग बट 0.06 मल्टिप्लाइड बाय 1 which is equal to 0.06. 0.06 it is same. इथे equals to 1 multiplied by 1 which is equal to 1. हे इथे लिहिलेलं आहे, हे इथे लिहिलेलं आहे, हे इथे लिहिलेलं आहे. पुढच्या न्यूमेरिकल मध्ये 1.5 नी मल्टिप्लाय केलेलं आहे. हे इथे लिहिणार मी. इथे डायमीटर आहे 1.5 आहे आणि 1 multiplied by 1.5 which is equal to 1.5. खाली लिहिणार मी इथे 0.06 multiplied by 1.5 which is equal to 0.09. 1590. It is like this. आलं आता थोडंसं क्लिअर झालं का? मल्टिप्लाय प्रत्येकाला करायचं आहे, पण फक्त कशाने मल्टिप्लाय करतोय त्याचं 100% करायचं आहे. पर्सेंटेज किती आहे? Crown radius is nothing but the 100% of the diameter. Crown radius is nothing but the 80% of the diameter. 80% म्हटलं तर 80% of the vessel diameter. हे महत्वाचं आहे. 80% of the vessel diameter, 6% of the vessel diameter, 10% of the vessel diameter. It is always talked in terms of the percentage of vessel diameter. Percentage of vessel diameter मध्ये असल्यामुळे म्हणून आपण त्याला मल्टिप्लाय करतोय ते. अजून काही करत नाहीये. मल्टिप्लाय का करतोय? इट इज द पर्सेंटेज ऑफ व्हेसल डायमीटर. आलं का? अंडरस्टँडिंग झालं का? की अजूनही कन्फ्युजन आहे? जर असेल काही डिफिकल्टी तर विचारा.